Chapter 9.3, Sample Spaces. So a sample space is the collection of all possible outcomes from an experiment. So you can use the sample space to find the probability of an event. Now, these are not events that have actually occurred. They are all the events that could occur. So here at example 1, make a table to find the sample space for rolling 2 number cubes colored red and blue, or rolling 2 dice, a red one and a blue one. Write the outcomes as ordered pairs. So all of the numbers in red represent the red dice, and all of the numbers in blue represent rolling the blue dice. So if I roll those 2 dice, I could roll a 1 and a 1 on each dice. I could roll again and roll a 1 on the red dice, but a 2 on the blue dice. 1 on the red dice, 3 on the blue dice, 4 on the blue dice, etc. I can also go the other way. I could get a 1 on every blue dice, but the number on the red dice changes. So this grid shows every single possible outcome that I could get. B asks us to find the probability of rolling at least 1 3. Well, everything in this column will have at least 1 3, and everything in this column will have 1 3. Now, this one does not count twice. It is one event. It only counts once. So I have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. There are 11 outcomes which have a 3, at least 1 3, out of a total of 6 times 6, 36 possible outcomes. So the probability of getting a 3 is equal to 11/36. Okay? So creating sample spaces can be time consuming. It can take a lot of space. It can be tedious. Make sure you develop a method to make sure that you get all of the samples. A table is one example, but let's take a look at another option for a sample space. Example 2 is going to use a tree diagram. So suppose you're going to travel on a river. You have 2 choices of boats, a kayak or a rowboat. You can go upstream on 3 smaller streams to the north, northwest, or the northeast. What is the sample space for your journey? So the sample space is going to start with my boat. I can take a kayak, or I can take a rowboat. If I'm in a kayak, I can go 3 directions. I can go north, I can go northwest, or I can go northeast. If I'm in that rowboat, I can do the same thing. I can go north in my rowboat, I can go northwest, or I can go northeast. So my outcomes then are kayak, north, and typically you would write out the full word, but I'm running out of room. Kayak, northeast, or kayak, I'm sorry, that should have been a west. Kayak, north, you get the idea, northeast and northwest. So I'm starting with the kayak and I'm going north, starting at the kayak and going northwest, starting with the kayak and going northeast. Or I can take my rowboat and go north. I can take my rowboat and go northwest. And I can take my rowboat and go northeast. So suppose you select a trip at random. What is the probability of selecting a kayak and going directly north? So this and means I'm doing both. I want the kayak going north, which is this guy right here. There is one option of me getting in a kayak and going north, but there are 1, 2, 3, 4, 5, 6 different possible outcomes. So the probability of taking a kayak and going north is equal to 1/6. So creating a tree diagram is another option. Now, some tree diagrams can continue on. So if I was to have another 2 options, let's say, my tree diagram can get bigger and bigger and bigger. This one I only have a boat and a direction. Perhaps it was a choice of lunch on your tour. You could have all of those different options. So let's take a look at example 3, the counting principle. Suppose there are m ways of making one choice and n ways of making a second. Then there are m times n ways to make the first choice followed by the second. For example, you can choose a shirt in 5 sizes and in 7 different colors. Then you can choose among 5 times 7 or 35 different shirts. So instead of making a sample space or making a tree diagram, let's use the counting principle to figure out how many different sandwiches you can order when you choose 1 bread and 1 meat from this menu. So here I say I have 1, 2, 3, 4, 5 breads. And I have 1, 2, 3, 4, 5, 6 meats. So the counting principle says if I have 5 choices for my first choice and 6 for my second, if I multiply them together, I can make 30 different combinations. Rye roast beef, rye turkey, rye ham, rye pastrami, rye salami. There are 6 choices just right there. So if I multiply, it's a much faster way to determine how many combinations I can have. All right, that's it for examples. This is going to be time consuming and take a lot of space. That's okay. Use it and make it neat. If you have any questions after your CYUs and QCs, come see me.